Internet, as all of us know, is a computer network. Information is exchanged between computers which are located globally by the use of internet. Any two internet connected computers have the ability to communicate with each other by exchanging information. This can be text, image, audio, video, basically anything. And these computers can exchange information in very less time, even though they are miles apart. Thanks to the well-crafted applications of physics and chemistry, we have a decent internet hardware which facilitates us to make the communications faster. The computers on the internet are either server computers or client computers. Server computers are those which serve the requests of the client computers and send them the files that they are requesting. Client computers, on the other hand, are those which send requests to the server computers asking for files or information. Internet is now becoming almost a common requirement for everyone living on the earth. Every organization or company is using internet to digitalize their work. We are using internet for online shopping, social networking, to read and send important details, all of which are worth a lot of money. You know it is serious when we are talking about money. So if we are doing things which are worth money on the internet, you know internet should be secure. Just like how banks have a tight security, internet also must have. So in this video, we will see if internet is really secure, and if it is, how secure it is. Consider a case where you are logging in to your online internet banking account. You visit your bank portal on your browser, put in your username and password and click login. When you click on login, the credentials you entered must be validated to see if they are correct. For this to happen, your credentials are to be sent to the server computer of your bank, which may be located miles away from you. Your data containing the credentials are broken down into packets and are first sent to your home router. From there, they will be forwarded to other routers and packet switches on the internet. Finally, they reach your bank's server computer where the packets are reassembled and then the credentials are validated. But notice here that the packets of data containing your credentials, which means your username and password, are forwarded to many routers and packet switches before they reach the bank server. This means that your packets of data are almost public while they are being transmitted. Anyone can eavesdrop on you and can easily capture these packets of data. Or anyone who owns any of the router on the path between you on your bank server can reassemble all these packets and they can get your credentials.
And I need not explain to you what might happen.
And I need not explain to you what might happen if anyone has your bank credentials, right? Well, this is the same with your email credentials or your Facebook credentials or the payment information that you are sending to some online shopping website or any other critical information that you are sending on the internet. So, is there any way using which we can directly send our data packets to the web server without any intermediate routers? No, there isn't. Or at least for now, there is no technology to achieve that. We know we can't prevent anyone from eavesdropping us. So, what do? Well, we lock our data with a key. Just like how we keep important things in a box and then lock the box with a key and keep the key with us very securely, we lock our data with a key before we send it to the internet, and we keep this key very secure with us. Now, if anyone wants to read our data, they need this key to unlock it first, and only then they can read it. So even though if someone captured the data that we are sending, they will not be able to read it since it is locked and they need a key to unlock it, and they don't have a key because the key is secure with us. This is the general theory of cryptography. Now the question arises, how do we lock digital data since we know it is not some physical thing and it is actually stored in a computer? And what is meant by a key? Is it a typical key we use to lock our doors or something like a digital key? Obviously we can't use a typical real life key to lock the digital data. We will want to use something which is digital and which can be stored and processed by the computers. Well, we use math to achieve this. We use math to generate digital keys and to lock the data digitally. Suppose we want to lock or encrypt the data saying hello world. There are many encryption algorithms available, out of which AES and DES are widely used. When we encrypt or lock the data hello world with a particular key, hello world becomes something like this. Does that text make any sense? No, right? That's exactly what we want. Anyone who is eavesdropping us or capturing the packets we are sending will be seeing this gibberish text and they have no idea what this means because it is encrypted. Please note that encryption is basically done in binary level, and the key that we are talking about here is nothing but a stream of binary data, that is zeros and ones, one after another. So if we want to decrypt this text, we simply pass it into a decryption function along with the keys. Let's say the key is K. So if the key is correct, we successfully decrypt this message and we now have the original text, that is hello world. Now this original text, it can be your bank credentials, or it can be your Facebook credentials, or it can be anything that you're sending on the internet to a web server. Also note that the encryption and decryption functions are just pure applications of math. We will cover more about encryption algorithms and how they work in another video, but for now just understand that you generate a key using which you can lock or encrypt the data and also unlock or decrypt the encrypted data. This way we make things more secure. Let's apply this technique for the earlier online banking scenario. We first generate a key and then encrypt our banking credentials with the key, and then send it to the bank server through the internet. Now if anyone is doing a man-in-the-middle attack or secretly capturing the data packets we are sending, they will understand nothing because everything is encrypted. Once the packets are received by the bank server, all the bank server has is encrypted text. Obviously it will need a key to decrypt this text, but as you could see, we haven't shared our key with the bank server yet. So until we share the key with the bank server, it cannot validate our credentials and we will not be provided access into our online banking account. So we send the key to the server. But what if an intruder has captured the key that we are sending to the server? If he does, he can now decrypt all the messages or data that we are exchanging with the bank, and he can basically read all these things. So we either share our key, making sure that it is not captured or understood by any intruder, or we use some other approach. We will use public key cryptography to solve this issue. We first generate two keys, namely private key and public key, using the RSA algorithm. Let's say the public key is K1 plus and the private key is K1 minus. The private key is used to decrypt the data and the public key is used to encrypt it. Please note that the public key cannot be used to decrypt the data. We keep the private key with us and we won't share this with anyone, not even with the bank server. We now send the public key to the bank server in plain text. Even though if someone captures our public key, it doesn't matter because they cannot decrypt any data using this key. All they can do is just encrypt the data. On the other hand, our bank server also has a public and a private key. It makes the public key publicly available to everyone. Let's say the public key of the bank server is K2 plus and the private key is K2 minus. We first obtain the public key of the bank server and then encrypt our credentials with it and then send it to the bank server. Once the encrypted data is received at the bank server, it decrypts it with its private key and then validates the credentials. If the credentials are correct, it then sends our bank information like the account number, balance, or anything which is involved in the internet banking to us. But before sending it, it encrypts the data with our public key. Once we receive the data, we simply decrypt it with our private key. So all the information exchanged between us and the bank server is encrypted and decrypted in the same way. In this way, any intruder who is trying to capture our packets and steal our information will have absolutely no idea what is going on. One question arises: what if we can brute force and guess the private key using our computer? I mean, yeah, we know computers are good at doing things at a faster rate, so why can't we just brute force or crack the key somehow? Well, it's almost impossible to brute force a key because that is how algorithms are designed. You cannot brute force a key with your home computer. It may take millions of years to crack a key with your computer because it involves a lot of processing and a lot of guessing. It is impossible to crack a key with the present technology we have, but who knows, in the future we might be having computers which are fast enough to crack a key in a matter of minutes maybe. Surely we can't expect how far technology may go. But wait, have you listened about quantum computers? They're expected to be arriving soon, or they have already arrived. Anyways, they are much more faster than the normal computers that we are using. And yeah, they are a threat to the current cryptographic techniques that are employed on the internet. So we should see how things will change. So thanks for watching this video. This is Teja signing off, and hit the like button if you liked it and comment down below if you have any doubts regarding this video. Don't forget to subscribe and check out other videos on my channel. Thanks for watching. Cheers.